Hello, and thank you for joining us for the Rise Innovation interview series. Today, I have Dr. Chris Mattmann. He is the IT Chief Technology and Innovation Officer at NASA Jet Propulsion Labs. First of all, thank you so much, Chris, for joining me and everybody watching. I've been inspired by you a few different times, both at Clubhouse, listening to you and some of the innovations that you've been working on, and as well as even with your jogging, inspire me to walk again. So I really appreciate you being here. Why don't you tell everybody kind of who you are and a little bit about yourself?
Sal, thanks so much for having me on the program, and shout out hi to your audience. So I've been in JPL. I've been at the Jet Propulsion Laboratory, which is NASA's national lab or federally funded research and development center, an FFRDC, for about 20 years. And, I usually divide it into kind of like two eras for that. The first 10 years I was at JPL, I was working on instrument and science data systems for both earth science, planetary systems, deep space. Basically, the work that I was doing was building up the teams that did data processing for them. And during that time, I became the chief architect in our instrument and data processing. I worked on half a dozen missions, data systems and archives, and basically kind of built the next generation of them as the world everyone was becoming a sensor, everyone had iPhones, everybody had these amazing cameras, instrument and scientific instrumentation also commensurately grew in its ability to collect data. We went from the era of tens of gigabytes after a decade in missions to 100 terabytes in the first 3 months. We went from the era of tens of jobs of data processing per day to 10,000 per day. And so basically helped architect and build the systems, infused a lot of open source, helped incept and create some of the biggest open source projects like Hadoop, helped to build that, at Apache, Nutch, Lucene, Solar, all the major search engine systems, and then my baby, Tika, which we call the digital Babelfish. The second decade that I worked at, JPL and NASA, the first decade you learn kind of everything that's wrong with the way that you make the sausage, and you want to improve the sausage making. And so, what I found during that time was that it's hard to get a lot of IT dollars and computer science money at NASA because they're just not spec'd for that. You got to find the agencies and the dollars in the government that have it. And so that led me to DARPA and the defense agencies, which get a lot of funding for computer science and things like that. And so helped work with JPL, NASA, and DARPA to build a really big kind of bidirectionally beneficial program in basically creating a new data systems technology to help, catch bad guys on the deep and the dark web, human trafficking, weapon and arms trafficking, counterfeit electronics, and apply that software back to JPL and NASA Earth science missions. So built about a $70 million program doing that the first 5 years of my second decade. And then the last 5 years, I took all the things I learned about data scientists, about AI, machine learning, and brought it over to IT. And I became the deputy CTO in the department. And the last year and a half became the CTIO, Chief Technology and Innovation Officer. So yeah, a lot of diverse interests. Really excited to talk about science. Really happy to be here today.
Amazing. Some of the projects you work on, it's amazing. Now, I heard you briefly talk about Tika and kind of how you positioned it and how you started utilizing it. Can you share with the audience a little bit about that?
Yeah, you got it. So Tika isn't just what you eat if you go into Indian food, and I love that too, but it's what we call the digital Babelfish. Like Hadoop, which grew from this big ecosystem of search engines and data systems projects that were really trying to emulate Google and build all the Google systems, like Google File System, Google MapReduce. Hadoop did the same thing. Tika was the part of the search engine systems that we split out that was responsible for automatically identifying any type of file on the internet, and why that's important is you may not know when someone's going to bring you a tranche that they got when they, raided Osama bin Laden's hideout. You might not know when someone's going to bring you, data that's really important to human trafficking investigation, and it's terabytes of data, or financial fraud, like in the case of the Panama Papers, or financial international tax havens and things like that. And when they do, you need to quickly assess and determine, hey, if I hand you this tranche, it's got PowerPoint, it's got Word documents, PDF, you got to be able to quickly sift and sort through and identify those file types. And then when you do, you got to be able to extract out the important information from it, the text, the metadata, the language of that text and metadata. And then within that, the people, the places, the things, the locations, and their connections. And so that's exactly what Tika does. The reason we call it the digital Babelfish is if you're familiar with the Hitchhiker's Guide to the Galaxy, You put the Babel fish to your ear and you can understand any language. Well, it's the digital Babel fish. You give Tika any type of file and it tells you everything about them. So
I love it. And that helped in finding criminals, fraudsters, and human trafficking, drug trade. I mean, like, it really had a deep impact, correct? If I'm understanding correctly.
Yeah. If you look up on Wikipedia, Tika was the key technology that was used to solve the Panama Papers and that won the Pulitzer Prize in journalism in 2017. And so for your audience, the Panama Papers, you can read about it. But basically, if you're unfamiliar with it, really important people around the world, prime ministers of Iceland, actors, actresses, very, very just, high access type of people. They use and exploit international tax law to kind of avoid having to pay taxes on their money and their wealth. They basically create these shell companies. This is still going on today, it happens. But, they go to these sort of holding companies to create these shell companies. And so what happened was in 2015, there was a big leak of data from one of these holding companies called Monseca. And that leak was about 11 terabytes of data that made its way out onto the internet, and journalists began investigating it. About 400 journalists that were part of the International Consortium for Journalism. And imagine again, it's that Osama bin Laden use case, that Zero Dark 30. You get a tranche of terabytes of data. What do you do with it? Well, the journalists, unbeknownst to us until 2016 and 2017, they picked up Tika and they started analyzing and looking at the connections between the people, places, locations, and they basically found out, Hermione Granger, Emma Watson was storing her money in a shell corporation. The Prime Minister of Iceland was. And then they published that. And that publication was the Panama Papers. And that's what won the Pulitzer Prize in journalism in 2017.
Amazing. Such cool projects. What was your favorite project that you were involved with over your career? And you had a long career. What is like the thing that still gives you goosebumps till today?
Outside of Tika and the Panama Papers, and that's probably what I'm most known for, and probably the favorite one. I'll give you and the audience a little different one. Probably my favorite project on the science side was a project called the Airborne Snow Observatory, or ASO. I was the compute lead for that project after I had sworn off working on missions. This was a really innovative mission, and it had a short time span. And so I was able to kind of, step in and apply some of the technology program development I was doing. ASO, in the Western US, we have water shortage, even though we're right on the ocean, here and things like that. You can't, because of, salinization, desalinization, and the expensiveness of that, we can't just take the ocean water and create water. And so we get most of our water in California, Nevada, Arizona, Utah, from the Colorado River Basin, as well as the Sierra Nevadas, and really the mountain snowpack. The snowpack accumulates water when the sun melts it at a particular rate. There's runoff. The runoff is accumulated in aqueducts and places like that, and dams, and then released to the community and governed by water rights, really ancient ones that are like 100 years old, that date back to the 1800s, and kind of really screwy here. Our way of measuring that to date, and even after ASO, because it hasn't been fully scaled out yet, it's being scaled out, is really people going up into the snow and sticking poles in the snow to measure it. And obviously that's perilous. It could cause loss of life. It's not accurate. It's not great. And because of that, 40% of our measurements of how much snow to accumulate, how much water to keep in the dams is usually wrong, and we waste a lot. And that's why part of the reason we have droughts and things like that. So what ASO did is it took a LiDAR instrument, which basically is like a radar. It bounces signals off of things, gets a backscatter pattern back to get really, really high resolution estimates of things like depth and how much of things are left. We used a LiDAR, a dual scanning LiDAR on ASO. We put it on a plane. We measured snow depth, how much of that snow is left for accumulation. And then we used a spectrometer, which measures reflectance of light, to look at how quickly the snow was melting. And obviously humans affect that because of things like black carbon and dust that gets on the snow and that make it melt faster. So, industrialization basically makes the snow melt faster and also screws up our estimates of that. So on ASO, we had a spectrometer and a dual scanning LiDAR, and we flew a bunch of flights in the Western US, and basically the snow off when there was no snow and the snow on seasons over multiple years. And basically now it's a capability that has been commercialized. There's a company called ASO Inc., But I was part of the team that basically built ASO, the whole system for it, a remote data processing system that we deployed up in the Sierra Nevadas in the Colorado River Basin. And the real catch about ASO is that unlike most NASA research missions for Airborne, we had to process all of the data in less than 24 hours.
Oh, wow.
To basically provide it to, modelers and forecasters at NOAA and as part of the California Department of Water Resources in order for that data to be useful. And so, yeah, it had really deep timing constraints and had this really kind of interesting remote data system and kind of remote cloud and disconnected environments. And so I really did enjoy that project. It was a great project.
Sounds like a fascinating project. So the outcome, I'm assuming, is they want to see how much we have left over time, right? They do some type of data matrix over time, analyzing, hey, you guys are going to run out of water X days, or X years. I saw a recent documentary that was talking about global warming, and it was talking about how that the caps are melting, and it's because of the lack of reflective material that's left, which would be snow, that reflects back the heat. And I was wondering why they don't paint it with elastomeric or something along those lines that could deflect even if the snow melts. But I guess that's a huge job to clean up the mountains, paint them, have it stick, and then put the snow back where the snow will come back. So I was just like, well, if they figure that out, it would help a lot, right? Because elastomeric really works.
That's a great idea. And there are actually people that are working on like that in a small sense. And it actually got born out of really the relationship between science and arts, and why people talk about STEAM today: science, technology, engineering, arts, and math, and not just STEM. Artists paint things all the time and then look at sort of reflectance related to that. And the scientific term for the measurement of that reflectance is called albedo. And so, yeah, it's looking at the albedo measurement. And so, yeah, there are, analogous folks that work in cryosphere or snow research and things like that, looking at that, where they've been looking at, can they do things similar to artistry, like by, using some type of, again, reflective paint or things like that. But obviously, yes, the big is scaling it out and
scaling it over. Yeah. It's crazy. Wow. But it's cool because I think, I believe that something like that will happen because we do need to find a solution for that. This brings me right into my next question. What is it that you consider is innovation?
Hey, well, fabulous question. So for me, innovation is sort of the following things. It's being customer obsessed and walking backwards, kind of from that, and really looking at the existing business processes and ways of improving them, either reducing the amount of time that it takes to do them, so innovating the existing things, either through time reduction, change in resources, or through some new amazing idea that kind of adapts business processes. The other for innovation is really having a novel solution to, validate or invalidate scientific hypotheses through technology. It's conceptualization, it's design, it's thinking through, in areas where we're not sure there's a problem yet. It's being data driven, it's looking at things that we've done in the past and trying not to repeat them in the future. And then it's also being data driven from a perspective of using data to explain what we're seeing that's anomalous, all the way to basically having an innovative culture, making it part of your culture, recruiting for innovation, looking at the next generation, realizing it's multidisciplinary, and that it's not, in the past, looking for innovation and technology, it's not just about finding computer scientists, it's finding, people who were psychologists and, teaching them tech. It's taking atmospheric scientists and showing them Python and how to program. It's taking Python programmers and explaining the arts to them and the design and creativity. It's all of those things. It's having and recruiting an innovative and diverse workforce. So it's all of those things.
Love it. I often hear from past interviewees, they say there's two different types of innovations. There's brand new innovations, which are usually on the bleeding edge and sometimes very scary to approach for financial reasons, for legal reasons, for adversity reasons. And then there's also innovations that, just like you said, just change the processes a little bit to improve the entire system. And I believe we're kind of in an explosion of that era with, you have these pre-trained transformers now that make it a lot more accessible for a lot of the developers that have not had access to these types of platforms. You got Google Colab that can even host small projects and you got a bunch of resources now that you did not have before, such as OpenAI's Codex. And you got also what we're working with for the Rise Innovation Program is we're working with GPTJ Jinji, which is their own open source codex sort of thing, which is really exciting because then you can get, you can get help coding, which really improves the entire cycle of things, right? You can code faster, you can find snippets. Yes, you still need to know code, but this makes it a lot easier. I love it. What are some inspiring words that you could say to everybody that is in the Rise Innovation Program or just looking to kind of get into this innovation mindset and want to create something new and something world-changing?
Well, I've got to have a quote from one of my favorite movies, Terminator 2: Rise of the Machines, with Eddie Furlong back in the day. No fate but what we make. There's no fate but what we make for ourselves. The future is not written. And, it's funny, it's in Terminator 2, and probably a lot of people nowadays haven't seen that movie or may not, and it might be kind of foreign to them.
Don't call us old yet.
Probably dated myself, but, there, Sal, and you. But yeah, related to that, I mean, that's kind of the way I approach it is, a lot of people think, well, you can't escape some local minimum and things like that. The future isn't written, and there isn't any fate but what you make for yourselves. If I had told you, 30 years ago, kid growing up in a trailer in Santa Clarita, go get his PhD, become the CTO of JPL, things like that, you might not have believed that. And so there isn't any future that's written already. You can write it for yourself, work hard. Another, quote for me, I tell my folks too, is also just rise and grind. I might not be the smartest person in the room, but I certainly will outwork you. And, I've always lived by that. And it really, you meet a lot of people that are passionate. It doesn't matter where they came from, whether, they were born into it, whether, they went to the best schools in the world, whether they didn't. You meet these sort of passionate people, and those are the criteria, the characteristics that you typically see. They're very passionate, they're obsessed with, the things that are related to innovation and what they want to work on. And so that would be what I would share, with your audience and your communities. Those are a couple of things that stick to my mind.
I love it. The future is not written. Rise and grind and work for it. And it's true for all things, really. It's the rule of 10,000 hours. You become an expert in anything that you really have a passion for and dedicate to learning, you will learn. And today, I love education, but at the same time, today you have, outside of EDU, plenty of opportunities to learn online, video, in whatever format that you can learn in. I'll tell you, my business partner for AI Exosphere, he's great at reading. He loves reading. He will read everything 10 times over. Me, I will skim through stuff and then ask him, hey, did you read all of it? But I learn much better from video or creatives or
Sure.
illustrations.
100%.
So if I look at a map, for me, planning flow-throughs and how everything works, that's my specialty. But it's because I'm a visual person. So I have to have a whiteboard. I die without, you will not get any use out of me at all without a whiteboard, because if I can't put it down on paper, I can't picture it.
You have an excellent future career for you, Sal, at JPL when you're done dominating the startup industry. So anyways, whiteboards are basically pro forma for us. So
I can't do it. So we moved it. I'll tell you a little story about our office in Orlando. When we got the office, it was just an empty office. And I was like, okay, before we even start, let's order some stickers to put up on the wall so I can cover the wall so I can start writing and mapping out Haley. And he's like, what, stickers? I was like, yes. The whole wall I whiteboarded with that whiteboard sticker. Now it looks a lot nicer because we renovated it, but it was just one huge wall with just scribbles like that I can understand, but most people can't. So
that's great. That's a great story.
Thank you. All right. There is one final question, and I know you are opinionated about it, and you have good kind of insight into it. Is the ethics of AI? It's a hot topic now. But what are some? It's beyond ethics, really. I want to get down to what you think about the ethics of the software we develop, and then on top of that, how do you tackle unforeseen ethical issues that arise out of really powerful software?
So Sal, I'll address sort of the first question, then hit the second part. So just ethics in software, in general today, and AI. Our big concern, we are, for the reasons you stated, that the wide availability of, pre-trained AI models, its accessibility, our access to cloud computing, and, again, the wide availability of training on this nowadays and whatever, people are deploying AI and existing models, and some of which in a way that, scare people. This is why they were worried about releasing OpenAI, and its power to generate really believable text, is that, they didn't want to release the OpenAI, model initially for that. They did end up releasing it, but they were concerned that, people might use it in ways that, again, could create disinformation, could, do bad things or whatever with it. In general, I would add sort of two things to that to kind of consider. First, when building training data sets for AI, there has to be, an effort and thought put in to creating balanced data and to thinking through bias as it relates to that. And obviously the greatest quick example in computer vision of that is related to smart cars, electric vehicles, in which a lot of the early work on that, the data sets, they did not include, say, minority persons or folks that were, say, disabled, and thus, smart cars never saw, say, someone in a wheelchair to train on. They didn't know what to do on it. And so the bias came out, or maybe they didn't see people of color or, things, because
context.
The data,
they didn't have context.
Bingo, the data was not built that way. And so building the training data set, we got to take that context into account. That's one. The other is we need, every time to make a prediction, when our models make predictions after we've trained them, we need to provide the confidence and the bias, because, a lot of times what you'll hear, and you hear this on the news or the media, or even in science sometimes, is like, well, here's your 3 decisions and go ahead and pick decision A. And what you didn't know is that the difference between A, B, and C was like a fraction of a half a fraction of a percent. And they're all terrible choices, or they're all, slightly better. And so every time you make a prediction, you need to provide the confidence with it so that people can interpret and understand the bias. And so media and other news for 100 years have believed, unfortunately, that the broad community, that was too much for them. They just want a decision. They want a snappy reason why. And actually we're past that ethically, and you need to provide the bias and the confidence. So that's your first part. Your second part, kind of your question, I'll kind of go in sort of 2 arenas, for that, related to, AI ethics, with this revolution, that's coming, there's going to be a lot of, I would say, I won't call it like reskilling, but, our skills are going to change, kind of related to that in certain communities in which, parts of their job have been automated. Hell, data science, which is highly skilled and, large salaried areas, they are trying to automate that. So it's not like they're just trying to take away, say, the positions of people driving cars. They want to automate data scientists. And so even data science, could have to be
I have a story about that.
I would love to hear it. And so when we do that, we just have to take, and it's your point, Sal, context, into account. We don't want to say, oh, learn to code to all those people. That's missing context, and that's a dismissal. We have to find ways to gather those subject matter expert knowledge while we're reskilling them and put them to work in really interesting positions in providing that knowledge and also training them for the next tasks that they're going to take on that are going to make them efficient. So those are a couple things I'll point out. Go ahead with your story.
So we had a data scientist on the team at the beginning of the project, and we did find quite a good number of assets for data science in AI, and some great JIT libraries that did a lot of his work, and they did cut costs. But I always look at AI as a way to improve life. Sure, it could also, if not properly controlled and given context, it could do harm. And I think it's really important to realize that. But at the same time, our lives have improved on such a drastic level because of AI, and it's the tip of the iceberg. We're just getting started. We're just like literally the last 10 years was about fixing the hardware so it can be capable of powering these AIs that are now open source and available to the market. So I think if your heart is in the right place, and you got to realize, you have to approach whatever innovation you want and just consider the consequences. I don't think it's ever going to replace us as humans. I think it's going to make things easier. Even with Haley, by the way, we have a dashboard. It's a control dashboard for any user that can operate 4 conversations at a time. It has to be human monitored because, like you said, sometimes context doesn't pan out even with your most diligent programming. And it just that way. So what would you do for unforeseen biases that you've maybe launched? So Haley, we have a skill platform where developers can develop skills. So if they develop a skill that we approve, and then somehow it alienates somebody in some way unbeknownst to us, how do you handle things like that you didn't seek for it? You did everything you could. You did your due diligence. You did your everything you could to code or uncode bias out of the AI. Look at Facebook as an example, right? Facebook started with the idea of connecting people, and now there's people depressed, and there's all these violations of privacy, and all of these, like, it became a whole different thing. But those, I'm sure, when they first launched, wasn't it foreseen? They're like, we're going to connect people. People are going to talk. They're talking on our platform. What do you do in those cases?
So the first thing I want to put a plug in for, and I teach at USC. I teach graduate classes in computer science. I teach a class called, it's the intro graduate course. It's called Data Science in Large Environments. But I've been teaching this for 10 years. There's a great paper. It's almost 10 years old actually, in IEEE Computer in 2013. It's called Big Data's Big Unintended Consequences. And the point of the paper was sort of the following. It's like a 6-page paper. It's not super long. It was looking at the ease and availability of taking previously closed loop systems on the internet and connecting them together. And the easy way to explain the paper was, they realized on Amazon, if they took, say, your shopping history and noticed you were trying to buy a bunch of, say, I don't know, baby girl clothes, and you combine that with like your location data from Yelp and certain, geographic other information, that they could tell you were pregnant before your mother knew, or things like that. And, that was one of the things like that is basically, as you start to combine data in, that previously was just, again, in companies, closed loop systems, and as companies and governments were moving to being more open loop and mashing data together, and how that was possible, it basically said, you're going to have all these unintended consequences related to privacy, related to everything you just said, Sal. So that paper predicts the current, situation. It's an amazing paper. And basically a couple of things that they say.
It's readable. Everybody that's watching this should read it.
Absolutely. And so basically, a couple of things they say is like, A, you can't stop this. It's going to happen. What you can stop is basically your digital footprint. You could decide not to be part of it, but that's hard and has its own consequences if you do. Like maybe it cuts you off from your friends. Maybe it doesn't provide you government services, and things like that. So
or maybe it wouldn't have gotten us this interview if it wasn't for social media and the likes.
Bingo, right? Absolutely, a great point. And so all of that. So it says you can't really stop it. Ways that you can stop it have other unintended bad effects or whatever. The other, it talks, and I'll just throw in my own color on this. I tell students as well, it's also signal to noise. So given the fact that with or without these capabilities, either commercial companies who are now forming, almost like G20 like conglomerates, and things like that, and governments and things like that, have always had some capability to listen or to see or whatever, as has been revealed, not even in the last 10 or 20 years, but in the last 50. We have intelligence agencies, we have, I tell people it's a signal to noise issue. Given that with any amount of effort, they're going to be able to get information about you and what you do and things like that. Really, what's your signal versus what's your noise, kind of that's out there. And so a lot of times, I'll tell people is maybe you should be more noisy, in ways that dilute the signal, or maybe you should just lower your signal, and then that way. And so these are sort of my recommendations to people to kind of think about in this environment. It's like, and I've even fallen prey to this, don't like exercise yourself from, say, social media, or just divorce yourself 100%, but maybe change the way you post less, go off the beaten path, change the times that you post, don't have a consistent pattern. Maybe don't necessarily always go to the same place to buy a thing, just things like that. Because to be honest, at the level of scale that we're talking about now, was it 9 billion people in the world and things like that? It's all about the opportunity cost, which, by the way, governments, corporations can do. It's the opportunity cost to collect and gather that data about just you, given the other noise that's out there. So my advice to people is just change your patterns.
I love it. It's like a fog screen. You're laying a fog screen. You're like, I'm everywhere. I went to this place, this place, this place. There's nothing you can follow. Yep. Love it. Thank you so much for joining me. Any final words for the audience?
I really hope people really take into account, again, and I want to emphasize this, the A in STEAMs, being a creative, and Sal talked about this before, he's a visual person. Being creative, being in arts, that's so important. And you have to mix that with the engineering, the math, the science and technology. And the A is so important. And if you're an A person and you are creative, artistic, we need you too. We want you. Come be part of it. So
I love it. I love it. Thank you so much. I really do appreciate it. Where can people find out more about Mr. Chris Mattmann? Doctor, Mattmann, let me say doctor.
Chris is fine. Mattmann.ai, Sal, MATTMANN.ai. I've become a sentient being and part of the internet. That's my website, or you can find me on IG at Chris Mattmann. Thank you.
Love it. Thank you so much for joining us, and we'll see you guys on the next Rise interview series.